All right, IB Math AASL2. Last class we learned the chain rule of derivatives. Today we're going to learn the product rule of derivatives. And who knows, the two may shall meet in between at some point. So cryptic, jolly. All right, the product rule. It's really for things where there's two functions being multiplied together. So if you have an f of x where u of x is times v of x, so you can spot two functions that are being multiplied, then the derivative of f is the derivative u of x times v prime of x, so u of x times v prime of x plus v of x times u prime of x. I think it's a little complicated to look at that and be like, okay, I get it. Yeah, I mean, you can get it just by looking at it. But to be honest, TBH, guys, if I can be honest for a second, I really just think of it as first d second plus second d first. The d means derivative. So it's like first times the derivative of the second. I guess I could put that out. It's like the first function times deriv of second. And then plus second function times derivative of first. So first d second plus second d first. So with this example, my first function is a nice little polynomial, and my second one is also a nice polynomial. So this one's fairly straightforward. First d second. So first means just dropping the first thing down and not touching it. You just leave it there. And so first d second. Now d second means taking just the derivative of 2x minus 1. So that's 2. But then I have to add second d first. So second means keeping the 2x minus 1 by itself, and then the derivative of the first, that's a straight power rule. You're just dropping the powers out, popping them out, dropping them down. That's 3x squared plus 6x, and that's it. Now, do they want me to play cleanup on that? Oh my gosh, they do. Okay. So if you start to, distribute and stuff, you distribute that 2 to 2x cubed plus 6x squared plus 12, and then over here, we're going to have to FOIL these things to get 6x cubed plus 12x squared minus 3x squared minus 6x. Then you got to combine a whole lot of apples and oranges to get our final result, which is 8x cubed plus 15x squared minus 6x plus 12. So that's the final derivative, all simplified. If you go back and look at the original equation here, if I had given this to you guys with only the power rule, you could do it. You would just have to multiply this all out. You'd have to multiply x cubed with both of these things, and then this with these with those, and like get all these terms and combine like terms. But eventually you could get it down to like a polynomial and use the power rule. But I think sometimes that becomes too much work. That's just quicker to use the product rule. Ooh, you guys, a double whammy. We're going to have to rewrite this. Now, the reason I call this a double whammy is because if you look at the two functions, the first function, very straightforward, an x squared. Nothing's fancy about that. But the second function is a chain rule. Do you guys see how there's an inside and an outside function? Like the inside is x squared plus 1, and the outside is something to the 1/2. So we're still going to do first d second plus second d first. It's just that when we do d second, it's going to have to involve a chain rule. A chain rule within a product rule, if you will. Okay, first d second. So first the x squared. Now, d second is the derivative of this guy. With the derivative of that guy, it's a chain rule. So I have to do derivative of the outside with the inside intact. So that's bringing the 1/2 out in front and then leaving the inside intact. So we get 1/2. I'll just pop that in parentheses. Inside stays the same, and then we drop the power down 1, so subtract 1 off the 1/2. But then you have to do derivative of the inside. So that's still just the chain rule. So derivative of the inside is 2x. So far, I wonder if I can color code this. This is first, and then d second is all of this. It's just that the d second involved a chain rule. But we still haven't finished the product rule. So we did first d second, but now we have to do second d first. So second is x squared plus 1 to the 1/2 times d first, which is just a 2x. Because, the derivative of x squared is just 2x. Okay, how much cleanup do they want us to do here? Really, it's just moving any negative exponents to the denominator. And they do tend to change a power of 1/2 back to a square root. So, let's see. One thing I'm spotting, let's use a different color, is this x squared times this 2x. Well, not times the 2, just times the x is going to give us x cubed. Another thing I'm spotting is that 2 times 1/2 is just going to be a 1, so those are going to go away. So I'll take it in stages here. The 2 times the 1/2 is just 1, and then so we get x cubed times x squared plus 1 to the negative 1/2. Yeah, I didn't touch the second part, but now let's move things to the denominator and make any powers of 1/2 square roots. Two moves at once, guys. Bring the 2x out in front of the radical so it doesn't look like it's part of the radical. There it is. There's the whole, that's the derivative. Okay. Find the equation of the normal to the curve, where the curve is this, and then we're going to figure out where the equation of the normal at the point 0, 1. It's nice that they gave us a point and not just an x value, because if they gave us just the x value, we usually plug it into the master equation to figure out the coordinate that it goes through, but that part's already done. Let's talk about how we rewrite this guy so we can start to take a derivative using the product rule. So no derivative yet. I'm just going to change the square root of x plus 1 into x plus 1 to the 1/2, and then I'm going to bring the basement up and make it a negative power. So now I have a first and a second function being multiplied, so I can do first d second plus second d first. But I guess technically both the derivative of the first and the second are going to be chain rules because it's a function inside a function. Man, we are really just screaming ahead with this here. Okay, first d second. Here's first. Now d second. Notice there is an inside function and an outside function. So we have to do a chain rule for the d second part. So first d second, d second is a chain rule. It's the derivative of the outside, keeping the inside intact. So the negative 3 would come out, the 2x plus 1 would just chill, and then we drop this down to negative 4. But then you have to multiply times the derivative of the inside, so that's just a 2. So far, I've just done first d second, but the d second was a chain rule. Then I have to do second d first. So second, I'm just going to let that 2x plus 1 minus 3 just be what it is. And then I have to do derivative of the first. So first d second plus second d first. But this d first right here is technically a chain rule, but I even hesitate to say it because the derivative of the inside is just 1. So I'll write it out. The derivative, x plus 1 to the power of 1/2. The 1/2 would come out in front. And then the derivative of the inside would be unchanged. And then you drop the power down 1, so that's negative 1/2, times the derivative of the inside, and that's just a 1. So first d second plus second d first. So that's the derivative first. But this derivative of both of these parts were chain rules within the product rule because they were functions inside of functions. Okay, what should we do? Let's maybe clean it up as much as we can. Some things I'm noticing is that this -3 times 2 is going to be -6. This guy's going to have to go downstairs. This will be changed into a square root. So the top is going to be -6 square root x plus 1. And then we're kicking the 2x plus 1 minus 4, or to the -4 down to the bottom. It's 2x plus 1 to the 4th. And then in this right here, a 1/2 times a 1 is just 1/2. Now I see we're going to have to kick 2 things to the basement. Did I do that right? Hold on. Oh my gosh. I'm sorry that my phone keeps going off. Did I mess up something? Oh no, I didn't. Okay. So yeah, both of those are going to have to go to the denominator. So we get like a plus... 1 is going to be the only thing in the top. And then in the bottom, we'll have a 2x plus 1 cubed times x plus 1 to the 1/2. But really, I shouldn't even write x plus 1 to the 1/2. Instead of writing it all again, we'll just make that a square root. Okay, what's happening? Let's zoom out. Find the equation of the normal. To find the equation of a normal, you guys know how to do that. You take the derivative and feed in your x value. We've just been taking the derivative, but we finally got the derivative to a place where it's simplified and we can feed in the x value. The x value is a 0. That's kind of nice because looking at this, I was like, oh boy, that's going to be rough to plug things into. But the fact that they gave us a 0 actually makes it kind of nice because if you did -6 times square root of 0 plus 1, that's the square root of 1 all over. And then put a 0 in for the 2x part, that becomes plus 1 to the 4th. So this is like 1 to the 4th. And then over here, the 1 just chills. Put a 0 in for the 2x, and you get 1 to the 3rd. Put a 0 in for the x in the square root, and you get the square root of 1. So there's all these 1s everywhere that really don't do much. So the simplification is that this is -6 plus 1. No, I did something wrong. What did I do wrong, you guys? 1, square root of 1, 1. If you put in a 0, we should get -11/2. I did this last night. It worked out perfectly. Let me see if we can spot it. Okay, 0 there, that's 1, -6. That seems all hunky-dory. And then if you put a 1 there, 0. Oh, you guys, I messed up my derivative. There's this 2, like let me zoom in right here. I forgot that there was a 2 right here in the denominator. So when I moved from there to here, I forgot that there should be a 2 downstairs, which means there's a 2 here, which means we're not adding 1. We are adding 1/2. Nice, like that problem solving in real time? Yep, that's right. Everybody makes mistakes. That's why there's erasers on pencils. Now we need a common denominator. -12/2 plus 1/2 equals -11/2. Now, -11/2 is the slope of the tangent. To find the slope of the normal, you take the negative reciprocal of that. So the normal slope is 2/11, which means the equation of our normal is a y equals mx plus b, where it's y equals 211x plus b. But then to find that b value, we're going to take the coordinate of 0, 1 and plug it all the way in down here. 1 is equal to 2/11 times 0 plus b So the 0 cancels out, so b is equal to 1. So final answer, y is equal to 211x plus 1. This is equation of the normal at the point 0, 1. Okay, you guys, that's all I got for us today. So now we have, in our derivative toolbox, we have the power rule, which we've done a million times now, and we have the quotient, no, excuse me, not